First, let's talk about the general compound interest formula, which is up here. We're going to talk about two new formulas today. I'll talk about the compounding continuously here in a minute. So you've got this formula up top, and it is not as complicated as it looks, because you've already kind of been doing some of it with just that general growth formula. On this one, and this is probably the one part that might be a little complicated. The A value is the final amount, whereas whenever we talked about just the general growth equation, that A value right there, that is the initial. And on the compound, the A is going to be the final. The P value, that is what is going to be the initial. Your R is the rate. You still need to convert that to a decimal, so your 4.3% would be 0.043, so on. T is going to be time still. The one thing that is completely new is N, and that's going to be the number of times that it is compounded per year. Which, let me explain what that compound means. So if you have, I'll give you just a Mickey Mouse example. If you've got $100 in an account and it has 1% interest, whenever it compounds, it takes 1% of your balance, which 1% of 100 is what? 1, and it adds that interest onto the current balance. And then if the next time it was compounded, 1% of $101 is $1.01, you would add 1.01 and your new balance would be 102.01. So the compounding is the adding of the interest on top of the current balance. That's what that means. So you'll need to know, whenever you have these words right here, you'll need to know what number to put in for N, which if something happens daily, how many days are there in a year? 365. So if you have a word problem that says it is compounded daily, 365 would be your N value. How many weeks are in a year? Months. If it happens quarterly, how many times a year is that? 4. Don't get it confused. It's every 3 months, but it would occur 4 times in a year. Semi-annually. 2. Okay, same thing. A lot of people will confuse 6 with that. It's not. It happens every 6 months, but it's only happening 1 time every 6 months, so 2 times a year. And then annually would be 1. So those are really the values that you're going to use for N. And they're not that hard. Most of you already know what they are just by the word, okay? There is another way to compound something other than those, which gets into this compounded continuously. So I'll read through this and kind of explain a little bit. It says, hypothetically, interest can be computed and added to the balance of an account every instant, which is considered continuously. The exponential function most commonly found in nature is based on the natural base e. The number is denoted by the letter E in honor of some dead guy, but E equals this 2.71828, so on. So you need to make sure that you know how to put that into the calculator. You're going to use this a lot, and it is just second division.
What if I just come up with a number and then put a letter?
Now, you don't overthink it. The qualities of E is similar to pi. All right, it's a long number that has that ongoing decimal that never stops, and it's got a symbol that stands for that number. So just kind of think of it as a very similar thing as pi. So here are the main three formulas that you're going to use. All right, now you need to know when to use them. If you have a problem that has the word interest in it, you're going to use one of these two formulas. Okay? If it says that it is compounded daily, weekly, monthly, quarterly, semi-annually, annually, any of those that we just listed, you're going to use the compound growth formula. If the problem has the word interest in it, and then it says that it is compounded continuously, you're going to use that formula right there. You will hear me refer to that as a PERT. You just read it, a PERT. If it does not have the word interest in it, you're just going to use your generic a times b to the power of x. All right, so the word interest, that's really kind of the key thing that you need to find to know that you're going to use one of those two formulas. Let's look at these first couple right here. So on these specifically, on the compound growth formula, because there's so many so many variables, I would highly recommend that you make some kind of key off to the side. And this is something come quiz or test time, that if you have that filled out correctly but you get the answer wrong, usually that occurs whenever you just accidentally put something in the calculator wrong. You're going to get the majority of the points on that problem. Okay? So going through here, it says you deposit $2,100 into an account that pays 2.92 annual interest. So that initial deposit, that is my p-value, 2.92 as a decimal would be what? Okay, but what number am I going to put in there?
0.0.
No, point. Did you say 0.0? Did you say 0.0?
0.0292.
0.0292. Then it says, what is the balance after 1 year? So that would be my time. Just 1 year. Whenever you, and I didn't specify that, whenever you have time on these problems, you're not going to have to convert like today's or anything like that on these. I know last class we had some of those, that Bobcat question where we had to convert years to months. You're not going to have to do that on these. Okay? Time should always be in years. Then the end value for the quarterly here, sorry, it is quarterly, isn't it? Is going to be 4. So once you identify all those, in my mind, that's the hard part. Now you're just going to plug it into the formula. So on A, it's saying that it is being compounded quarterly. So I'm going to just plug all of those into that equation. And then if you want to simplify this and just raise it to the power of 4 instead of 4 times 1, that's fine. And on here you should have gotten 2,161.99. So because this is continuously, we're going to use the A PERT. I'm still going to use the initial amount. I'm still going to use the rate. I'm still going to use the time. It's just now I don't have to use the 4 for n because there won't be an n. So I'll fill in. So my initial is 2,100. I'm going to multiply that by E to the power of the rate times the time, which is just 1 year. So go ahead and put that in the calculator, especially since you hadn't really used the E button, and make sure start familiarizing yourself with that button. So on this one you should have gotten, or see if you got this, 2,162.22. Looking at number 2, says you deposit $800 into an account that pays 3.12%. So there already is my p-value, which is 800. My rate, which is going to be 0.0312. Then it says you don't deposit or withdraw any money. What is your balance after 4 years if the interest is compounded with the given frequency? So we got daily and semi-annually. So my time is going to be 4 years. For daily, my end value is 365. What is it for semi-annually? 2. Oh. Now, real quick, look up here. Max, I think it was either Max or Garrett, asked me a question that reminded me to bring this in, or to kind of talk about this. So, because I said earlier that all of these problems are going to be growth. All right. Now, whenever you had a growth problem, you would have to do the 1 plus whatever. This formula has that 1 plus that you normally do in the formula, so you don't need to do that. Okay, don't put 1.0312 up here as your rate. Just do the percentage as that decimal. So on this one you should have got 906.33. And everything on the second one is the exact same, except your end value is now 2 instead of 365. And so on this one you've got $905.46. All right, go to the back. On number 3, it says you have inherited an emerald ring that had an appraised value of $2,400 in 1960. The appraised value of the ring has increased by approximately 6% each year since then. What is the ring's value in 2019? Okay, so I go through there. What formula am I going to use on this one? The general growth. Why the general growth? What word did I not say just now? Interest. I never said interest. Okay, so you whenever you go through as far as the amount of work that's required, whenever you don't see the word interest, that means you don't have to find as much information. So your initial, we'll get there. So your initial is 2,400. What is my B value going to be on this? 1.06. It's an increase, so it's 1 plus, and then 6%. So now, what would I put in for time? Why 59? Because it's 59 years from 1960 to 2019. You should get that it is 74,689 $2,234.11. Four is a little bit different than the ones we saw above. It says, how much should you deposit in an account that pays 2.9%? So there's my rate. That's the first thing that it gives me. It says that it is compounded monthly, so what is my end value? 12. To have a balance of 2,300, so there is my A value, or my final. And then my time is 3 years. So now it's giving you the final amount, and you're trying to find the initial. You're wanting to save up for something. You know that it's going to cost this much. How much do I need to put in this account to get to that value? So I'm going to set it equal to the amount that I'm trying to get to. Then I'm going to plug everything else in. So if I gave you this problem right here, 5 times P equals 2,300. How would you solve for P? What would you do? Divide by 5. Okay, 5, P times some number, you would divide by that number. This is the exact same thing here. It's P times all of this, but they're all numbers. So what I can do is I can divide 2,300, and I can put it in the calculator just like this. And I don't have to do a whole lot of work. I'm just moving it all together. If you did not get 2,107.32, raise your hand so we can come look at your calculator. $2,108.58. Okay, so on this problem, I'm going to have you go through these 4 different steps here. But on each one, you're going to start off with 2,200. The one problem with this problem, it does not give you a time. I want you to do 5 years for each one of them. So you've got this $2,200 that you want to put into some kind of savings account. You're looking at 4 different banks that offer 4 different plans, and you're trying to figure out which one will yield you the most money. So I want you to go through those 4 different scenarios to figure out which one will give you the most money.
Why is it 5 years?
On the problem does not give you a time, so I just added it, just so that y'all have something to put in for T.
Wait.
And if you've done that first one, you should have gotten $2,554.61. There's the answer to the second one. Okay, so after doing all those, the first one would be the best option of those four. Okay, so questions on how all these work and what changes whenever you're given different information, all that good stuff. Yes, ma'am.
So, like, this is a net. Are we gonna have, like...
All right, going to the last one. Says you have $3,250 to put into a savings account that pays you at your bank that pays you 2.36% annual rate compounded daily. So you've got your initial amount, $3,250. You have your rate, which is 0.0236. It's compounded daily, so you want it to be 365. It says about how long will you need to keep your money there without making any withdrawals for you to double the value. So what is my final amount? $6,500. Okay, you'll see that sometimes whenever it's asking you to double in value. Okay, it's talking about that initial value doubling. So you would take 3,250, multiply that by 2, and that's how you would get 6,500. So what information do I not have? You don't have the time. Okay, so you would take everything you have. You've got your initial 3,250. You've got your rate of 0.0236 compounded daily. So I'm going to put X in for time, and I want to know when that is there. So how can I solve that? I can put this side, the left side of what I have up here, into y equals, and then I will go down the table and find the x value that has the first y value at or above 6,500.
30.
So whenever you do this, at 29, it is 6,443. And then at 30, it is 6,597. So it would take 30 years.